Hi, my name is Ben James. I'm the product marketing engineer for Multimedia Test, and I'm here at NI Week 2012 in the Automated Test Pavilion. What I'm here to show you today is our Multimedia Test Platform, especially testing IPTV set-top boxes. And so the first thing to understand is when I say multimedia test, I'm referring to audio and video test. Things like HDMI, composite video, component video, analog audio, and optical SPDIF. So the first thing to emphasize here really is our device under test. In this case, we have an IPTV set-top box. And the idea here really is that we're going to stream content to this IPTV set-top box over Ethernet, and it will decode it into the different audio and video signals, at which point we want to test those signals. So starting out in, for instance, a production test environment, the idea here is that we have 4 IPTV set-top boxes, and we're going to test all of these different interfaces on them in maybe an end-of-line test. So here we've got some content coming in, and if we look at our screen, you can see we're rapidly testing the 5 different interfaces. That's HDMI, composite video, component video, analog audio, and optical SPDIF, all in a matter of seconds, using teststand as our test sequencer, using this operator interface to kind of explain to a technician what's going on. Next up, I want to explain the difference between testing the signal integrity, making sure the signal is being formatted correctly and coming in correctly, to really analyzing the quality of the picture. So built on the same hardware, we are able to detect the quality of the picture coming in. With our software picture quality analysis, we run an advanced algorithm called structural similarity index metric, which replicates what a video test expert would score the video coming in. This is important because the industry as it stands today does this mostly manually, and so they're looking at the audio and video as a technician manually and ensuring that the quality is up to par. The issue with this obviously is quality. All these are subjective scores. We need objective scores here. It takes a long time. We need to automate this and make it a higher throughput. So if we take a look at this quality of the picture coming in, this is high def picture. We might be able to get a close up and see the different aspects of this video, but this is high quality. And the idea of picture quality analysis is that we have a reference stream and a test stream. And so with the reference stream, we take the first frame and compare it to the first frame of the test stream. And we run these 2 frames through the algorithm to figure out what the picture quality is. All this happens in real time before the next frame comes in. We run complete frame-to-frame comparison and the algorithm on top of that. In 1 second, that's 122 million pixels that we're running. So say, for instance, you're at home and somebody else is on the Ethernet. Netflix might give you a smaller network bandwidth in order to get your content. You might get a lower bitrate video. So if we take a look at the lower bitrate video, we've got the bird here, and it's actually a bit blocky. We can see that. But what's important is that we have an automated way to detect the difference in quality. So as soon as we run this, it's going to lock on to the same beginning of the sequence here, and it's going to give us a lower score on picture quality analysis. The same thing here, if we have dropped frames, we'll be able to detect that. And so really this is a multifaceted way of doing multimedia tests. Not only that the protocols are coming in correct, the signals are being formatted correctly, but then also that the picture is being reproduced accurately.